Okay, this is going to be a series of videos, so the one you're watching is only one of a series, and I do encourage you to watch the rest of them. Also, I encourage you to watch the full-length webumentary titled Global Warming, Myth or Reality, A Skeptic's View. It goes through the entire science behind global warming, but with this series, we're going to pick and choose some interesting pieces, and we're going to ask the viewer, does global warming pass the stink test? We're going to take a look at the science, and I want you to ask yourself, does that even make sense? Most importantly, ask yourself, if a big oil company produced a report like that, wouldn't the environmentalists be going ape nuts? Because what we're going to do is we're going to take a hard look at the science, and then once again, just ask yourself, does this pass the stink test? Okay, the first thing we're going to take a look at are the cornerstones of global warming. There's two charts, one showing carbon dioxide and the other one showing temperature. What we're going to explore here is the one having to do with carbon dioxide. This is the chart that they use or commonly use. As you can see, it shows carbon dioxide increasing with time. However, a closer examination shows you that prior to 1950, that CO2 level comes from a quote-unquote proxy of ice cores. They took it from the Arctic region, and the data post 1950 comes from Mauna Loa through what are called air grab samples or direct measurements. So right off the bat, the flaw you have is that they're combining a proxy with a direct measurement. They're combining two different methodologies, and you're combining two different locations within the world. We're not overlapping them. We're having one transition into the other. To highlight what this means is that just take a look at the two environments on which they took these two totally dissimilar air samples. One, you had a core or you took ice core, which is a proxy. It's an estimate of what CO2 was, versus flask sample or a air grab sample, which is a direct measurement. Okay, clearly the direct measurement's going to be a little bit more accurate. One of them, the Arctic, is sea level. The other one, the Mauna Loa, is 13,700 feet. So you're taking air samples from totally different altitudes. Don't you think that's going to impact the concentration of CO2? Once again, you're taking tropical, which is surrounded by CO2 spewing ocean, a CO2 spewing volcano, plants, animals, a lot of biomass in the tropical region in the Hawaii. And then you got the Arctic. There's no biomass around there at all. It's all frozen. So you're taking such totally dissimilar data sources. So once again, just from the very nature of where and how they're constructing this chart should raise a great deal of concern. More importantly, how could you ever reach a scientific consensus using this kind of data? If you can reach a scientific consensus based on a forecast, which very rarely can ever have a scientific consensus to begin with, how could you ever reach a consensus using that type of data? If there is in fact a consensus, it is more of a reflection that we got serious problems in the scientific community and their disregard for the scientific process than the fact that there's global warming going on. Okay, the logical question anyone that has even an elementary background of science should be asking is, why in the world did they go all the way down to Mauna Loa to get an air grab sample? Couldn't they have simply taken an air grab sample from the Arctic? Doesn't that make sense? If you're going to be taking core samples from there, wouldn't you want to take air grab samples from there so you at least have a continual chart from the same level and the same location? But they didn't. And that's one of my major flaws with this, is that clearly they're picking and choosing data sets to put together to make a case instead of following normal scientific procedure, which is you try to maintain as many variables constant as you possibly can. In this situation, they deliberately maximize the difference between their variables that they combined. That is awful scientific practice. And once again, if you can reach a global consensus, a scientific consensus with this kind of scientific practice, it shows it is a terrible reflection on the scientific community, because they're violating almost every basic scientific practice I can think of, and yet they're agreeing to it. That to me shows you that there is more activism behind this quote-unquote science than real science. And once again, this is the first of a series, so be sure to stop back and watch the other ones.